Assalamualaikum and good day everyone. My name is Azra and I will be presenting my paper titled A Comparative Study of Two Machine Learning Algorithms for Heart Disease Prediction System. The presentation starts off with an introduction to the problem. Then the second part will revolve around the problem statement, and the third will talk about some research objectives, and then we'll go to the methodology and results and discussion, and lastly we will conclude our findings. Heart disease is a general term for various illnesses involving the heart structure and capacity. Every heart disease is a cardiovascular disease, which includes diseases that involve heart and blood vessel-related diseases such as heart disease, heart attack, stroke, arrhythmia, heart failure, and heart valve problems. The large number of people to be tested take up more time in the overall process, which leads to the inefficiency of the healthcare system. Manual diagnosing will also lead to a medical cost increase for the hospital. Many machine learning is used to develop a more accurate prediction system to identify people with heart disease. Machine learning models used in this research is the neural network and logistic regression. The neural network consists of a series of inputs and outputs that are networked together to process information the way neurons would in a human brain. Logistic regression is used to describe data and to explain the relationship between one dependent binary variable and one or more nominal, ordinal, interval, or ratio level independent variable. It observes equations that estimates results from one or more independent variables, which is the input x, for a dependent variable, which is the output y. The machine learning algorithms in this research are coded in Jupyter Notebook. The motivation of this research stems from the following problem statements, where the number of people diagnosed with heart disease has increased over the years. It causes more people to wait to be diagnosed with the disease. This leads to the inefficiency of the diagnosing process in terms of time and human capital needed, and this also increases the medical test costs conducted, as more people have to be tested to confirm if they have heart disease or not. This research aims to use machine learning algorithms to classify and predict heart disease, as well as to compare the performance of neural network versus logistic regression. This research was carried out according to the flowchart, where we first identified the area of research and we performed a literature review in prediction system using artificial intelligence and machine learning algorithms. We formed the research questions based on the literature review. We found suitable dataset and programming language, and we identified the predictors or factors that contributes to classification via feature selection. We then trained the machine learning models using neural network and also logistic regression. After completing the training, what we did was we tested the models with unseen data, and then we compared the two performance in terms of accuracy and their F1 score, and then we developed coding relating to the variables that influence the decision of the prediction using data mining, and we checked whether they are accurate or not. If not, we go through the process of developing the coding of finding or relating the variables influencing the decision of the prediction using data mining. If we are satisfied, then the process would end. Data for this research was obtained from the Cleveland dataset that is obtained through Kaggle, and it consists of 313 samples. From this dataset, 11 out of 13 attributes were considered due to the feature selection performed on the data. The neural network consists of an input, hidden layers, and output. So the number of hidden layers is varied to find the number of hidden layers that results in the highest accuracy and the best F1 score. After increasing the number of hidden layers, it was found that the number of hidden layer of 1 gives the highest accuracy of 92.31% and the highest F1 score of 93.2%. Keeping the number of hidden layer fixed to 1. Next, 4 activation functions were tested in the study to observe which results in the model's best performance, and in this case, the sigmoid resulted in the highest accuracy of 92.31% and the highest F1 score of 93.2%. The cost function used for the logistic regression is the sigmoid, and it predicts the probability of the dependent variable, which consists of 0 and 1. Without a clear understanding of the confusion matrix, it is hard to proceed with any classification evaluation metrics. The confusion matrix provides a base to define and develop any of the evaluation metrics. Most of the evaluation metrics are defined with the terms found in the confusion matrix. So there are 4 components in the confusion matrix, which are true positive. These are actually positive, which means that the predicted as positive are correctly classified. And then we have the false positive, which are actually negative and predicted as positive. So they are misclassified. So then we have the false negative, which are actually positive but predicted as negative. So this is also misclassified. And we have the true negative, which are actually negative and they are predicted as negative. This means it is correctly classified. So the true positives in this research context are the number of correctly grouped cases of heart disease into the heart disease group. The metrics used to evaluate performance for this research are the accuracy and the F1 score. Accuracy refers to the ratio of the number of correctly classified cases to the total of cases under evaluation, whereas precision can be defined with respect to either of the classes, which means the precision of negative class is intuitively the ability of the classifier not to label as positive a sample that is negative, and the precision of a positive class is intuitively the ability of the classifier not to label as negative a sample that is positive. So the best value of precision is 1 and the worst value of precision is 0. Recall are actual positives from true positives. This means that for the ratio of the true positive to the number of actual positive cases, it can intuitively be expressed as the ability of the classifier to capture all the positive cases. It is also sometimes called a true positive rate. On the other hand, F1 score seeks the balance between precision and recall. It is considered as one of the best metrics for classification models regardless of class imbalance. So F1 score is the weighted average of recall and precision of the respective classes. Its best value is 1 and the worst value is 0. Data cleaning is required when preparing data. This process will remove or alter inaccurate, unfinished, unrelated, redundant, or poorly formatted data. The first data cleaning conducted is by checking if there are any missing values in the dataset used. Next, several histograms are plotted to show the data distribution of the parameters in the dataset. The results show that the data for age, cholesterol, and maximum heart rate achieved is normally distributed. A normally distributed data is more workable to achieve higher accuracy in prediction. The data for resting blood pressure is skewed, however, since the tail of the graph on the right side, which indicates a positively skewed distribution. The mean for this distribution is bigger than the median, which causes it to move to the right. So the skewness of the data will cause misclassification, with the minority class being poorly predicted compared to the majority class. Therefore, we performed a log transform, so the skewness changed or improved after the log transform from 0.7 to 0.28. The Boruta algorithm is used for feature selection to identify which features contributed to the prediction through iterations which defaults at 100. This algorithm works by adding randomness to the system by using random forests to solve the problem. The randomized system will then be combined with the original system. A classifier is then built for this enhanced system. At every iteration, it will decide which features are highly important and which features are not. So 6 important features are then identified as age, CP, which means chest pain, THALAC, which indicates maximum heart rate achieved, old pace, acid depression induced by exercise relative to rest, CA, the number of major vessels, and thallium stress. Before proceeding with data splitting, the data must be checked whether it is balanced or imbalanced. The data is considered imbalanced if the classification categories are unequal. Data must be balanced to avoid bias to the majority class and cause the minority class to be ignored in the classifying process. Data distribution of 20% to 40% or lower is considered imbalanced. For this data set, the data for negative cases of heart disease and positive cases of heart disease is 138 and 165 respectively. So the percentage for this data is 45.54% to 54.46%, which is considered balanced data. After checking whether the data is balanced or imbalanced, then we proceed with data splitting, where we split the data into training and testing dataset. We randomly split with 30% of dataset as testing and 70% will be allocated for training. So in this case, we have 212 training data and we have 91 testing data. A comparison is made between the two predictive models, neural network and logistic regression, in terms of their F1 score and prediction accuracy. And looking at the results, the accuracy and the F1 score of the neural network outperforms the logistic regression. As a conclusion, this research successfully compared two machine learning algorithms that can correctly determine whether a person has heart disease or not. The findings of this research align with previous researchers that found ANN to be superior to logistic regression. ANN with one hidden layer size with the application of the sigmoid activation function showed the best performance, and ANN with those settings performs better than logistic regression based on the comparison of the accuracy and the F1 score for both of the models. Thank you.